Okay, so let's zoom this in a little bit and get started. So when I see 26 and 24, honestly, that seems really big. So I'm going to divide by 2, something you don't have to do, but I think it's easier. And then that's 13, and that's 12. Well, that reminds me of a 5, 12, 13. So that means I'm going to put a 5 right here. But if you remember from the beginning of the chapter, you're going to have to show me that you know this length is not actually 5. So you multiply by 2, and it's actually 10. All right, so they want you to do sine theta, cosine theta, and tan theta. And they want it based on that theta. So this is opposite, this is adjacent, this is hypotenuse. You don't need to show that work, but sometimes it's easier for sanity. So 12 over 13, 5 over 13, and 12 over 5. I don't need you to find the value of theta. It's not on a graph. Okay. All right. But you could find the value of theta by doing the inverse sine of this. So you know what? I'll make a bonus. Why not? I'm feeling generous. So if you use any of these trig functions, and you can find the value of theta. So I'll pick inverse sine of 12 divided by 13, and it's 6738. So that means I know that theta is 6738 degrees. If I decide to do inverse cosine of 5 divided by 13, I get 6738. If I do inverse tan of 12 over 5, I get 6738. So no matter what I do. So that'll be a little bit of bonus. I'll give you an extra point for that. It's not much, but it's, hey, every point matters, right? Okay, so I want you to put this in standard position, find its reference angle, and do the coterminal. So in order to do that, I'm going to have to subtract 360 and subtract 360. Really, I'm just subtracting 720. Hopefully that's enough. So 1056 minus 720, and I get 336. Okay, putting it in standard position means it is in the fourth quadrant, 336 degrees. Standard position, check. To find the reference angle, I'm going to do 360 minus 336, and I get 24 degrees. That is my reference angle. Check. The coterminal means if I have the positive, I need to get the negative. So I'll go 336 minus 360, which ends up being negative 24 degrees. The reference angle and the coterminal are not always the same. It's a coincidence. Okay? All right. So now let's do this one, find the measure of the reference angle. I'm not sure why it's done twice. Subtract 360, 219. 219 ends up in the fourth quadrant, so I'm going 219 and 180. So 219 minus 180 is 39 degrees. That is my reference angle. Now, just to reiterate how the reference angle and the coterminal are not the same, if I asked for the coterminal of this, you would go 219 minus 360. And when you do that, you know that this is not the same as that. Okay. All right. Let's see. Find the value of the other sides. So if these are congruent, I know this is a 45, 45, 90. And based on the 45, 45, 90, the ratio is 1, 1 rad 2. So I multiply by 6 rad 2. So this side is 6 rad 2. I multiply this by 6 rad 2. Rad 2 times rad 2 is 2 times 6 is 12. That side is 12. And that's it. This is the one so many of you struggle with the most. So I plot negative 3, 9. Left 3, up 9. Always draw the triangle to hit the origin. Okay? And this value of theta is kind of what you're finding. Okay? So I'm going to do the Pythagorean theorem. 3 squared plus 9 squared equals c squared. 9 plus 81. Square root of 90. Tree it. 10, 9. 3, 3. So I get 3 rad 10. Now, I just want to show you something on the side. What I could have done instead is that I noticed, just want you to see it, negative 3, 9. I could have divided by 3 here. And that would have been 3 and negative 1. And what I like about that is it's a lot smaller. So 1 squared plus 3 squared is 1 plus 9, which is 10 square root. that would have been rad 10, but it's really 3 rad 10 because I multiplied by 3. But by doing what I just did, by showing that this is -1, 3, and rad 10, when I'm doing my ratios, it's going to be, I don't have to simplify because I already simplified here. So I've got to do sine theta, cosine theta, tan theta, cosecant theta. Yes, you have to remember this. Secant theta and cotan theta. Let me remind you, SCCS. That's how I remember it. So sine, let me label things. This is opposite, this is adjacent, this is hypotenuse. So that would be opposite over hypotenuse. Multiply by rad 10 is 3 rad 10 over 10. Okay. Actually, you know what? Let me show the original so that when I flip it, it's a lot easier. So this would be 3 rad 10. So when I flip it, it's rad 10 over 3, and that's done. But then 3 rad 10 over 10 simplified. Okay. If I would have done this, I would have had to go 9. So I just want to show you why I'm doing this simplified. I would have had to go 9 over 3 rad 10, which is 3 over rad 10. So by doing this, I saved myself some simplifying. Cosine is adjacent over hypotenuse. So if I flipped that, I get negative rad 10, rad 10, rad 10. You're not going to erase your work. I'm just showing it for space. Negative rad 10 over 10. And then tan is opposite over adjacent. 3 over -1 is -1/3. 3 over -1 simplifies to -3. The last thing I have to do is find theta. Well, I know theta is in the second quadrant. Here's the truth. This will give me the answer in the first quadrant. If it gives me the answer in the first quadrant, that means I'll find my reference angle. So let me just show you how to do all of them, okay? So inverse sine of 3 rad 10 divided by 10. Oops, what did I do wrong? Let's see. Oops, I think I have too many parentheses. Divided by 10. Okay. Oops, I have 100. All right, let's do over, so we want to be careful. Delete. All right, and I get 7156. So if I get 7156, that tells me that that's here. But I know it's over here, which means that's the 7156. But what I'm really trying to find is the value of this angle right here. So I need to go 180 minus 7156. So 180 minus 71.56, and that's 108.44. So I know theta is 108.44 degrees. That's the hard part for you guys. So that's going to be worth some points. I want to show you if I did inverse cosine. So if I did inverse cosine of negative rad 10 divided by 10, I get 108.43. Oh, actually, I think I might have rounded somewhere that I didn't round. So let me put 43. I think I forgot to round. Okay, I think that was supposed to be 57. So look it gave me the answer, so I got lucky. Let's do inverse tan of -3, and I get -71. If I would have done inverse tan tells me in this quadrant. It's not in the fourth quadrant, so that would be my reference angle. See how that matches up? And that's 7156, and that's what that is. So no matter what, you need to get 108.43 rounded to the nearest hundredth. Okay. Convert it from radians to degrees, so it looks like that says 155. I divide by 180, so I can go 155 divided by 180. Second PRB, oops. Second PR, oh, okay, let's do this again. Excuse me, all my sniffles. And I get 31 over 36. Don't forget to throw in the pi. Some of you will just divide by 5 and you'll figure it out. Because if you divide by 5, that's 3 and 1. When you divide by 5, that's 36. When you have pi, that's 180. That's 18. 3 times 18 is 54 degrees. Don't forget the degrees, you'll lose a point. All right, so I want the coterminal. So that means I'm going to add 360, and I get 110 degrees. Not sure why that got repeated. All right, let's look here. Find the unit circle, the exact value. Okay. First thing I have to do is change this to degree mode. So negative 180 divided by 4. So that's really cosine of negative 45 degrees. I don't like negatives, so I'm going to add 360, and I get cosine of 315. Okay? So if I'm doing cosine of 315, I know it's in the fourth quadrant. Yes, I want the positive. If you have a negative, I want to see the positive. It'll be worth an extra point. So this problem will be worth more than this one because you have to know to change the negative to a positive. This is 360. This is 315. Do your reference angle, 45, 45, 90. The ratio is 1, negative 1, right 1, down 1, rad 2. Cosine is adjacent over hypotenuse. So I get 1 over rad 2 over 2. If you can go straight to this answer without seeing that answer, I'm okay with it. Now, let's say you go, I don't think that's right. I can check it by doing the inverse cosine of that. So let me show you that. Inverse cosine of rad 2 divided by 2, and I get 45 degrees. But then you go, wait a minute, but 45 degrees is in the first quadrant. Yes, but that means your calculator only knows some things, so that's your reference angle. So then if you went 360 minus 45, you get 315, and it ends up in the fourth quadrant. So you're good to go. Let's do the next one, tan of 150. Okay, so that's 180. There's 150. 180 minus 150 is 30 degrees. Now we have a 30, 60, 90. So what's across from the 30? 1. That means what's across from the 60? Rad 3 and 2. But since you're going left, it's negative. Tan is opposite over adjacent. 1 over negative rad 3. Rad 3 is negative rad 3 over 3. You're not sure I'm right? Let's do the inverse tan. Inverse tan of negative rad 3 divided by 3. I get negative 30. The problem is my calculator only knows so much. So my calculator goes, hey, negative 30 is over here. But we know it's actually in the second quadrant, reference angle. It matches, you're good to go. That's the first page.